Hi, welcome to this video. In this video I will model these parts from the midterm exam during the summer semester 2017. I graded all of the exams today, all the models, and I will do them in reverse order of the in which you guys had struggles during the exam. So I will begin with doing first the fastener. Pretty straightforward. It was a 6 millimeter. I thought I put that in there. I guess I didn't. It was a 6 millimeter by 1.1 millimeter pitch. I took the specs right off of McMaster Carr's website. So we will begin by starting a new part. And I'll point out the issues that students had during all these parts. So first thing I want to do is come down here and change these to millimeters because the drawing has millimeters. Now one thing I didn't notice during the grading of these, and I apologize in it, I put the exam together literally minutes before I sent it to the testing center, and there were a few dimensions missing. I did not grade you for the missing dimensions. So if you got something that looked pretty close, you got full credit for that. Okay, so this here, the easiest way that I would find to do this part is on the front part to do a revolve. Because everything's round on it except for the hex cut on the top. So if we do a revolve, we bring in our center line, and I like to come off of the origin and draw my line. Hitting the S key to bring up this menu here, I'm going to bring out the straight lines, and so now I'm just going to kind of rough sketch it in. There's my head, there's the length of my threads, and then go back to 0. Okay, and now we'll bring in our dimension tool. Actually, let's do something here. Let's pull this out so we can get hold of that. Now we'll pull in the dimension tool. This here is 6 millimeters. This here was 21 millimeters. And then from here to here, being a diameter, is 6 millimeters. And here to here is 10 millimeters. Right? Yeah, 10 millimeters. 6. Okay. So there's the basic shape of our bolt. Now, I'm going to pause the video here for just a second. Okay, I unpaused the video. Apparently, some of you had problems interpreting the drawing. So this is the drawing that was given to you for the exam. As a PDF, it had all 3 parts in it. So this is the bolt, and the missing dimension on this one is the width of the hex. I gave you the depth of it, but I didn't tell you how wide to make it. If we look here, we can see this would be the diameter of the threads, and that's going out to about the same diameter, so point to point should have been about 6 millimeters. Again, I did not expect you to try and interpret missing dimensions. Your machinists, when you hand them a drawing and it's missing a dimension, they'll be on your desk saying, hey, Art, this is missing a dimension, put it in. And then you tell Rodney, just go back out and make your parts. Anyway, the biggest problem on this part was this dimension right here. This is a standard call out saying they're 2 times a chamfer that is 0.2 by 45 degrees, 0.2 millimeters by 45 degrees. The 2 times means that there's 1 here and 1 down here. That is a standard call out, and every machinist will know that it has to have a chamfer on each side. And it could be that this was too small. Some of you put a radius on that corner. If it was a radius, this would have an R by it, saying that it's a radius. And then also, One more thing too that was an issue here. Like this one is 0.8 by 45. A lot of you did the 0.8 along the hypotenuse of the chamfer. Standard dimensioning suggests that the 0.8 is from a linear distance. So either down the length of it or across the face. That is the 0.8. Again, I did not mark you wrong if you did the hypotenuse. I'm not here to teach you how to read blueprints. I'm just bringing this up as an FYI, so in the future you know that that's what it means on a drawing when you see that kind of a call out. So back to the model. So we have on this corner up here, we need a chamfer of 0.2 millimeters on this corner and this corner. And you'll see that it's got the 0.2 down the leg of the chamfer and not across the hypotenuse. And then over here we have a chamfer of 0.8. Again, it's 0.8 across. And I did that in 2 steps because you'll see this little infinity sign here. It's actually a chain link. That means that those dimensions are linked. So if you come in and change this one, it will automatically update all of them. It's supposed to update all of them. That may be something new in 2017 that only does the one associated with its corner. So see, even I learn something new every day. Okay, so there is everything round on this part. And now we'll just come up here and close our sketch, which opens up the dialog box for the revolve. We want to go around the center line because this is the only center line in the drawing. It'll automatically default to it. We want to go 360 degrees and we'll hit OK. And so there is our bolt. Now you'll notice in my drawing that because I took everything off of the center point or off of the origin, that's the word I'm looking for, off the origin, everything was black as I dimensioned it. Everything turned black. That means everything is fully defined. Now, if I didn't start here, you see that it's now everything's blue. Everything's still nearly full defined, but things can move. So by connecting that to the origin, everything turned black. That sketch is now fully defined. Okay, now we have everything modeled that is round on this fastener. The only thing we have left to do is to put the hex shape in it. So we'll bring that surface up and we will click on it and do a cut. What is that? Yeah, okay, that's, and then come in here and grab the polygon and draw it. Okay, so to make this just a little bit easier because I didn't give you a dimension and we're going to go 6 inches across the points. I'm going to draw another circle in here and make it a construction that is tied to that point. So now as the points change, that circle changes with it. That just makes it easier to define this to be 6 millimeters across the point. But you notice everything's blue still because it's not fully defined. It still has rotation. So we need to define the rotation of the part. And that can be simply done by grabbing any surface. Generally, well, not generally, there is a possibility in your design that this surface needs to be parallel to some other surface on your part, and you would do so. But for right now, in this part, it doesn't matter. So we're going to grab that and tell it to be horizontal. There we go. And everything's turned black, so it can't move. So this is now a fully defined sketch. And we'll hit the close button and go down 4.5 millimeters. And there we have our screw. You can have SolidWorks put on a threaded feature on this, makes it look like a real bolt. we don't cover that in this class. I think you can find a tutorial inside of SolidWorks if you're interested in learning how to do that. So that was the first part. So we'll save this as what is it? Fastener. Fastener. Summer 17. Okay, so the next part that we had that was next in line in difficulty was this clamp. It really wasn't too difficult. I don't think there were too many people that had real major issues with this. It was, again, the biggest issue was fully defining your sketches. And also, there's another missing dimension on this one, and that is the location of the holes, distance between them, or the location from the edge. When I designed this part for this test, I basically centered the hole on this edge here, but because it's not in the drawing, I could not penalize you if you didn't put it there. So again, I apologize. So now we will make this part. If I can get this out of the way, there we go. So again, we'll start with a new part. This one is in millimeters, so we'll change our units down here. Again, I like to start with the front, do an extruded boss. And again, to fully define everything, I'm going to start with my point in the origin, and I'm going to kind of sketch this out. I'm going to leave a gap there for the radius, come up, come over, gap radius, over, down, and then I'm left mouse clicking and dragging backwards across those to select all those lines and delete them. Okay, so now I want this one and this one to be collinear. They already are, which will make these two equal. These two here, I want those to be equal. These will come out equal. Oh, that was not collinear, those are horizontal. So if I make them collinear, now when you change one, they both change. Okay, and then we need a couple of radii, so we'll grab our arc tool and go from there. That's the wrong arc tool. Oh, sorry, I'm used to not tangent. 3 point. There we go. And do that arc and do that arc. Okay, and again, there is no indication. That's another missing dimension on this drawing, is the distance to the center point of this. However, you can go backwards because of this dimension here. So let's do it based on the information we have. That was not a trick question. It was a missing dimension. So if you didn't get that, you are not penalized. So let's do what we know. We know that this here is 30. We know that this is 18. We know that this is 25. And we know that this is 43. Oh, that looks real funky, so we can grab this and drag it over here. And let's do an equals on these two here. Okay, so to get this 43 reference that was in there, we'll grab that point in the center of that arc and come down to this leg here and make it 43. If we, that's 43 there, that's 43. Okay, and then if we grab these two here and make them concentric, and that brings everything in. Again, that was not, you know, I don't think I knocked anybody off for this because again, the drawing did not specify the center point of these two arcs. I knew when I drew them that those were concentric, but there's nothing in the drawing that would suggest that it would be so. So Okay, so we have that. Now we'll close that sketch. It brings up the boss extrude dialog box. I like to do mid plane and my distance, which is 25. And so there is the shape of the clamp. Now I come down here, and again, this is one of those missing dimensions. I'm going to do the extruded cut, and I'm going to draw a circle and another circle. There's a couple of ways to do this. The missing dimension does not imply that that is in the center. But this is the way it was intended to be. With this being a radius of 15, and you'll notice it's black and centered on that space. Now to make this one the same, I would use symmetry. We know that that part is symmetric there, so if we grab this, this, and this, and tell it to be symmetric, it's there. That was the way, sorry, I didn't mean to scream at you. That was the intended design modeling that I had expected when I created this part. So now that everything's done, we'll close the sketch, go to a through. We don't need to go both through all, and there is our hole. Now you could dimension that to the center with a 12.5 millimeter offset, and then whatever dimension you did here. But if you dimension it from the center and you come in and change the width of this to 50, your hole would no longer be in the center. And I just do that to point out, hopefully you learn from my mistakes that I made in my early days. Okay, so the only thing we got left to do is to put the little counterbore on top. So I'm going to grab that surface there, do another extruded cut, grab the circle, bring it parallel or coplanar to the screen, and draw a circle. I'm going to grab that radius there and that circle and make those concentric. Another thing you can do, oh, I already did. If I hadn't, you could bring that up until the center lines, make those two. And then we're going to grab those and make them equal. And then we have a radius of 12, so that would be a 24. And close the sketch, brings up the dialog box. Now that's cutting down. We don't want to cut that way, so we need to reverse the direction. And you can leave it with the blind or go through all. And there's our clamp. So it's pretty simple. Like I say, the biggest issue with this one was on these holes here. A lot of people didn't fully define your sketches. Again, maybe it was unjustified because there were no dimensions given, but there should have been some kind of, one of them had circles, 2 different diameters. Okay, so we'll save this part as not to open. We want to save. Save this as, I'm looking at there, not down here, clamp. Oh, and I didn't put a date. Oh well, we'll be fine. Okay, so now the one that caused the most heartache for students. I think a lot of you made this part a lot harder than it had to be. And I guess that's, in my defense, we gave a part similar to this last semester, and it didn't have the radius. Let's pull that sketch down so you can see it. It didn't have this radius here in it last semester, and that may have thrown everybody off. But the model itself was a repeat from last semester. So let me go through and show you how I would model this myself. Okay, so to do this part, we'll bring up a new part file, change our units to millimeters. And on this one, I'll start with the top instead of the front because we're going to build from the top up instead of from the side. It doesn't, it's not critical to which one you use. It's just personal preference. So I'm doing the top. I'm going to do an extruded boss. I'm going to pull down the polygon and do a 5-sided figure. Okay. So now, if you needed to edit this, change the number size, if you just click on any of that lines, come over here into the existing relations, or right mouse click on that and edit polygon, it'll bring up the dialog box for that, and you can change anything you like. I needed 5 sides, so apparently last time I did it, I had a 5-sided figure. Okay, so we now have our 5-sided figure, so now we need to turn all these lines black. So first off, I'm going to grab this line down here and come and make it horizontal. That just make it so that it can't rotate. It now just goes bigger and little. We'll pull out a dimensioning tool and come in here and give that inner circle a radius of 76 millimeters, basically from the drawing. So now we have our base. If we close the sketch over here, it brings up the extrude dialog box. We want to go 75 millimeters up. And there is the base of our bottle. Okay. The next step is going to be to put the loft in for the angled surfaces. So the first thing we need to do is a reference plane 108 millimeters up from that. So I'm going to select that surface because that's the surface that is referenced from in my drawing. And I'm going to come up here to references and do a plane. And look at that, 108 already, flip dimensions. And there we have a plane that is 108 millimeters from there. So I do that because if you ever wanted to check and make sure that you're correct, you can just double click on that. It pulls up 108 and it matches your drawing. It's just, again, one of the art-isms that I like to do myself. So now we got our 2 planes that we need to do the sketches for our loft. So first off, our base, we'll just come down here and create a sketch, and because we want it to match that surface, we'll just come over here and convert entities, which will take that and create a sketch for us of the edges that are already black because they're all tied to the edges of that part. Our next sketch will be up here. We need to have a round surface for the round top of our bottle. You notice that through the plane to the back, I like to keep it in the front, so I hit it again to bring it up front. Again, it's just another artism. I like to see where I'm working. So I'm going to draw a circle here, and I'm going to dimension it to the 30 millimeters from the drawing and close that sketch. So now we have the 2 sketches we need for the loft for the angled portion of our bottle. Again, I don't like looking at all these sketch planes, so I'll come in and right mouse click on the plane and hit hide, and it goes away. It just makes your drawing part a lot easier to look at. So we got our sketches, so we're going to come over here and grab our loft, and the profile curves are this one and this one, and there we have our angled surface. Comes right up off these edges and goes from a pentagon into a circle. Okay, now that the loft is done, we need to add the neck to the bottom. Again, keeping with the same method, we're going to reference it from the bottom of this part because that's what's in the drawing. So we'll select that surface, come up here and select the pane, and we're going to be offset 140 millimeters. And it's down there, but we want it to the top, so we're going to flip the direction and call it good. And we will select this plane and do an extruded boss. Do a double take to get that to the right direction, and circle. We'll take that circle and that edge and make them radial. And then we'll close our sketch, bringing up the dialog box. We're going to go up to surface, and we're going to go up to this one here, and right mouse hit OK. And again, we're just going to hide this plane. Right mouse click and hit hide. So there's the neck. And again, this part is also a victim of missing dimensions. The radius is not dimensioned. Also, the center point of the extra credit radiuses was not dimensioned. So if you put any radius in there, you got all the extra credit. But to put the radius in here, we'll select that surface, hit our radiusing tool. We want a 15 millimeter radius and hit OK. So there's our bottle, and then we'll just click this surface, go to our here we go to our shell, and we want a 2 millimeter. Show preview to the inside and call it good. And so there's what's required for the exam. Okay, now to do the extra credit, again, there's several ways to do all these things. This is what I would have done. If we look at the top of this part, we can see that this edge here is on the right plane, and it'll go all the way out. If we take the front plane, it doesn't hit the maximum corners, so but the right plane does. So we're going to do our cut revolve, a revolved cut around that surface. Again, it's not the only way to do things, but this is the way I would do it. I drew a line on here on that edge so that we cut to the edge. We'll need our radius of revolve. And then we need some radiuses. So I would bring this in, and this one, and this one, and click those two and make them tangent. Click those two, make them tangent. Click those two, make them tangent. Click this one, and with the control key down, hit that one and make those equal. We're also going to do one more thing here. We're going to bring this here and put it on that edge there so that that line is the length of that edge. You'll see why in a minute. Okay, so now we're going to trim away all the stuff we don't need. I have mine set up to where with a quick key on my computer in my office, if I hit T it does it, but I don't have that set here yet. So we'll hit the trim, and we'll trim off those parts that we don't want. We don't want that part, we don't want that part, we don't want that part, or this part, or that part. That leaves us with our radii that we need to do our cut. Okay, so again, the reason for doing this one to the full length is now I can come and quick snap to the center point and go to the center point of my arc there and make that line horizontal. This is now symmetric. So no matter where I go, it's always in the center of the part. Again, that was something that was not dimensioned in the drawing, so you wouldn't know to do that other than by visually looking at it and see it. So now we got to dimension these two radiuses. This one has a radius of 20 millimeters, and I can't see the other one is also 20 millimeters. So we could do a couple things. One, we could put a 20 millimeter call out on it, or we could also grab one of those in that surface and make those equals, and now they're all 20 millimeters. So again, the reason it's not fully defined now is because we don't have a dimension to the center of this arc here, so we don't know how deep to go with that. So I'm just going to put a dimension on here. Let's say that's 45. We'll look at it after we do it and see what it does. Okay, so we're fully black. Okay, but this time now we've got two center lines in here. So when we close this sketch and bring up the dialog, it doesn't know which one to choose. So with this box highlighted blue, we'll come over here and select that one to see that that's the one we want. And then we'll hit OK. And we probably need to do that after or before we shell. So I just drag the shell down after the revolve cut. Okay, we're not going all the way through, so we'll come and change this 45 here and make it a little bit taller. I'm just scrolling the center mouse, hitting this button, and there we go. Okay, so looks like maybe 60 millimeters. That looks like about the same as the drawing. So that's how I would put those radiuses on the part. It's plain and simple. And there we have a completed model. If you have any questions, please let me know. Thanks.